Okay, so now here's a key concept. Okay, so we've been looking at these parabolas. We've been able to identify the different parts of them. We know there's a vertex and that there's symmetry. Okay, so here's a key concept. For the parabola in standard form, y equals ax squared plus bx plus c, we know that it has a vertex, right? Well, we've been talking a lot about the x value of the vertex, but the vertex has the y-coordinate. So the vertex's y-coordinate is really important because that y-coordinate is the minimum or maximum value of the function. Okay, and here's how to know which is which. Okay, let's do a little graph first, okay? Now we talked about those little pieces A, B, and C, what we know. We know if A is positive, okay, or we could say A is greater than 0, we know that the graph will be happy, right? Because it's positive, so it's going upwards. We also know that if the A value is negative or less than 0, okay, we know that it's going to go upside down. It's going to be unhappy, right? Well, where's the vertex? Okay, we know the vertex is here because there's right in the center of that curve, and here's the vertex. Here's how we can tell if it's a maximum or minimum. When we're looking at this red parabola over here to the left, what is the vertex to you? Does that look like the lowest point or does it look like the highest point? Well, it's pretty obvious. We know this is the lowest point, so we call this the minimum value. So when A is positive, the vertex has a minimum value. And when we're looking over here, we see this vertex. It's the highest point of the parabola. We call that a maximum value. So when A is negative or less than 0, the vertex has a maximum value. So when A is positive or greater than 0, it's a minimum. When A is negative or less than 0, it's a maximum. So why do we care about this? Why is this a big deal? Well, here's why this is a big deal. We use this all the time in real life, in business especially. So here's when we would need to say whether or not something is a maximum or a minimum value. Okay, so I told you we're going to figure out why this is so important to us. And here is why a lot of people think this is important, because of this little thing right here. Lots of people like money, and it's an essential part of our daily lives. People who are in business are not in business, so they can figure out how to make the minimal amount of money that they need. They're in business to make the most or maximize the amount of money that they can make, right? So let's figure out how we can actually use a parabola to figure out how we can maximize a business. Okay, so let's just say Bob has a go-kart racing business, and this is my very, very sad attempt at a go-kart. It's really bad. Anyway, he has a go-kart business, okay? And he, right now, has about 300, well, I should say not right now, pre-COVID, has about 380 visitors per week who ride his go-karts. And he charges $35 per race, okay? Now, what do you think would happen if he lowered his price? You might guessed it. Hopefully you guessed it. He's going to get more people. So anytime we lower the price, there's more interest in what we're doing, right? That's called supply and demand. Little preview for your economics course. So he figures, well, there's about, every time he does a special, every time he lowers the cost by minus $1, he gets about 20 visitors more per week that he gains. Okay, so he has more people coming if he lowers his price a little bit. Now, obviously, we don't want to lower his price so much that he has too many people and the lines are too long and it's costing him something, right? So we want to figure out what's that sweet spot. What should he do to really maximize his business and make the most that he can with the most amount of people he can. So here's how we're going to do it. We're going to talk about how does a business run? Well, there's this thing called revenue, which is how much money is brought in at the end of the day, okay? And revenue is, in this case, is the price times the number of attendees, okay, right? So if our price was $35, but we're saying, okay, how much should we subtract from that, right? How much should we decrease? We're going to say let X equal the discount, right? Or how much we're discounting the original price times. Now, we do know that every time we reduce the money by $1, Bob figures out, okay, there's 20 visitors more. So right now, normally we have 380 attendees, right? And as we subtract every dollar here, we add 20 more people. So for every $1 in price, we add 20 attendees, okay? So let's figure this out. So revenue, we'll call this a function of R of X, where the price is 35 minus X. We're trying to figure out how to maximize it, right? And we're going to multiply it by 380 plus 20X. All right, so let's just do that math, okay? We're going to use our faithful friend FOIL to multiply binomials. And here we go. We're going to go 35 times 380, that gives me 13,300. Outer, that gives me a positive 700x. Inner gives me a minus 380x. And the last term is a negative 20x squared. Well, what do we have here? What we're looking at is we're just looking at a quadratic function. So we know this is our biggest power, so we're going to put that first. We put that in descending order. Negative 30, 380, and 700. If we combine them, because these are like terms, actually, we're going to simplify that, and we've got 300. Oh, it's still on erase. Silly. So 320x, and there's our 13,300. So here we go. We know our function for all of his revenue is this. So remember, we want to maximize it. So what are we really wanting to find? What piece of information would tell us where the maximum is? Okay, if you said vertex, you're right. So remember, for vertex, we know the vertex x coordinate equals negative b over 2a. Well, we have a quadratic function here, don't we? We have our values of a x squared plus b x plus c. So here, let's write this down. A is negative 20, b is 320, and c is 13,300. Let's see if we can find this vertex in order to maximize it. So here we go. The x value of the vertex is negative b all over 2 times a. So we've got negative 320 divided by negative 40. Well, we know a negative divided by a negative is a positive. We can cancel out these zeros because they both divide by 10. And 32 over 4 is 8. So if X is 8, does that tell me what our maximum revenue is? No, it tells me what our, remember what we said X should be? We said X was the discount, right? Well, we said we decided in order to maximize revenue, we need to discount the price by 8. Well, let's find out that total revenue, right? So if we know R of X, meaning that the discount is now 8, equals negative 20 times 8 squared plus 320 times 8 plus 13,300, which we got all from right here. And now we're going to find that value of our y, okay? This function, you can replace it with the value of y in order to find that maximum vertex. So here we go. We plug in the value of 8 in for that we got from the vertex. Now here comes our value for y on the vertex. So here we go. And we're going to use, I'm just going to use my calculator for this, okay? And we've got 14,580. So that's his maximum revenue, which is a really fun way to be able to do it, because that way, you know, poor Bob doesn't have to run a special every day to figure out what this would look like. He can actually use math to know exactly what he should charge right from the get-go.